Here what your answer is going to look like for this one. And you'll see that there are 1, 2, 3, 4, 5 different rows where you end up with a negative value for S1, S2, or S3. So this solution is not feasible because of the negative 60. This one's is not feasible because you have 2 negatives. This one has 2 negatives. This one has a negative, and this one has a negative. All right. Now I want to show you all of these points and to show you why these non-feasible ones are not going to work. Now down here at the bottom, they said, solve the problem graphically. I've done that, and I want to show you these points. So the first thing we're going to look at is problem number 40 and 54. So you can see 0, 0, 0, 15, 0, 7, 3, 0, 7, 0, 2, 5. We have excluded these two because of the negatives. So these are not feasible solutions. So let me show you the solutions that are feasible. 0, 0, 0, 7, 3, 0, and 2, 5. If you do the problem graphically, you'll see those 4 numbers or those 4 points are the corner points of the feasible region. This is what the feasible region looks like. 0, 0 is there. This one is not feasible. It's 0, 15. 0, 15 is right up here. It's a point that intersects with the y-axis and one of our lines, but you can see this point right here is not part of the feasible region. You can see it here because it gives you a negative value for S2. 0, 7 is right there. 3, 0 is right there. 7, 0 is way over here. It's not part of our feasible region. And since it's not part of our feasible region, it's not one of the points that we check. You can see that in here because we get a negative 20 for one of our variables. So we know that that solution is not possible. And the last one, 2, 5, is right here. And so the only ones that we evaluated that we would evaluate in the graphical method would be the corner points. So we've done that here, and you can see 140 is the largest, so that's the max, and that would be the solution to this problem. Down here, I put not only the x1 and x2 in, but I also indicated the s1 and the s2. But our objective function only contains an x1 and an x2, so you can really just ignore the s's when you're trying to find the max. Again, you can see the same 4 values here as here. The other problem, this is what it looks like. There are 5 different points that are corner points of the region. 1, 2, 3, 4, and 5. And there they are. This point right here, the 1640, it's not actually part of the feasible region. It's right there. And you know that this isn't one of the points that we need to check, because when you check it here, 1640, one of your s's is negative. So that's not a feasible solution. So you're only going to have 1, 2, 3, 4, 5, and you can see them. 1, 2, not feasible, not feasible, not feasible, not feasible. 3, 4, not feasible, and 5. You have 5 different possible points, and that corresponds to the 1, 2, 3, 4, 5 corner points of this region. Here's one of the points in your table that wouldn't work. You can see on the graph, it's not part of the feasible solution. Here's a point in your table, that 0, 120. When you go to 0, 120, you can see that a couple of the s's are negative, so it's not going to be one of the corner points that would lead to the solution. All right, I'll let you look at this after class, but please make the connection between all these points that you see that intersect, or 2 of the inequalities intersect, or lines, I should say, and compare that to these tables. The other thing is that the basic variables are the variables that you set equal to 0. So in number 40 here, the third row, 1, 2, 3, the basic variable would be x1 and s2. All of the other variables are what we call the non-basic variables. Those will usually take on values that are, well, they could take on zeros, I suppose. All right, so we looked at one way to solve linear programming problems here. Works okay. You can see for two variables. And we started off with two variables because we can graph those. All right, I'm going to show you the simplex method today, and it's a matrix method, and we're primarily going to use the graphing calculator program, so I'm going to show you that as well. On the notes, you're going to see a bunch of text, and so I'm not going to cover that text. I'm going to go right to the problems and define some of these terms as we do it. There's a nice flow chart here that takes us through the steps of the simplex method. It involves doing elementary row operations, and the row operations are the same ones that we used in the matrix section. So the first thing we're going to do is some parts. They give you some homework exercises where you do parts of the entire simplex method. And so we have this matrix down here. It's actually called a Tableau. It's a labeled matrix, a fancy matrix, one that has column labels to it. I also label the far left or the far right column in a Tableau like this. I label it as the RHS, the right-hand side, because that's usually the numbers on the right-hand side of all your E-systems equations. The number of rows or number of columns that you have correspond to the number of variables in the problem and the number of constraints. You can see that this inequality here, or this problem here, had two constraints because it had two slack variables. Here's your objective. Now we're going to, when we start a problem like this and we take it through the simplex method, we continue to work until we find the optimal solution. And the optimal solution in this case is the maximum, because we're doing only maximum problems today. And the maximum solution will be found when you see in the bottom row that there are no negatives. So for this one, the maximum has been achieved. You see it's going to be in here somewhere because there are no negative numbers in the bottom row. Over here, however, you'll see a negative, a couple of them. A negative in the bottom row. If you see that, then that means that the solution is not there. All right, so x1, x2, s1, s2, p, that's the objective, and then the right-hand side. And those labels actually go outside the Tableau. They're kind of identifying a column, but they're not part of the matrix that we're going to enter in. So 1, 4, -2, 0, 0, 10, and 0, 2, 3, 1, 0, 5, and 0, 5, 6, 0, 1, 35. The first thing they ask you to do is to identify the basic variables. So the basic variables, the way you do it is you go through the row, and you identify usually a 1, doesn't have to be a 1, but you're identifying a number for which there are zeros everywhere else in that column. So for example, in the first row, you see a 1 here and then zeros for the rest of the column. So the basic variable is going to be x1 because the 1 is here and the column label is x1. So the basic variable here is x1. In the next row, you go over till you find the 1, make sure that there's zeros everywhere else. And then so for the second row, here's where the 1 is, zeros everywhere else, go up to the top, s2 is the basic variable here. And finally, the last one, As you go over, you see a 1 here, zeros everywhere else. So here's the column numbers that you're looking for, and the column title is P. So those are the basic variables. So the initial solution then is this. We always set the basic variables equal to 0. So x1 is equal to 0, s2 is equal to 0, and p is equal to 0. All the basic variables will be 0. The non-basic variables will be everything else by process of elimination. So we've already identified x1, but we don't have x2. Oh, sorry. The non-basic variables are the zeros. I'll show you how to find the basic variable values in a second. Okay, the non-basic variables are x2 and s1, and both of those are 0. The basic variables, what you do to find the value is you go all the way over here to the right-hand side. So the basic variable here is 10. The basic variable of this row, you go all the way over and you get 25. And the basic variable of the last row is going to be 35. Basic variables, non-basic variables. Now you can see that this solution is, I mean, I know it's kind of hocus pocus here, magic, but if you wrote the 3 equations that correspond to these 3 rows, this is what you would have. You would have x1 plus 4x2 minus 2s1, 0, 0 equals 10. That's this row here. If you write an equation for the second row, you have 0x1 plus 2x2 plus 3s1 plus s2 plus 0 equals 125. And then finally, for the last row, there's 0x1 plus 5x2 plus 6s1 plus 0s2 plus p equals 35. So if we set the non-basic variables equal to 0, that is x2 and s1 are equal to 0, you can see that x1 is going to be equal to 10, x2 or s2, 0, 0, s2 is going to equal, that's a 25, and reading the last equation here, when you put zeros in for x2 and s1, you get p is equal to 35. So that's how you can find them just by looking at the right-hand side. The basic variables are equal to these numbers on the right-hand side, and all the non-basic variables are equal to 0. All right, so identify the basic and basic variables. We've done that here. A. Find the corresponding basic feasible solution. Well, here it is. When you identify the values of all the variables, here's the basic solution. And then determine whether the optimal solution has been found. An additional pivot is required, or the problem has no optimal solution. All right, so for this one, since there are no negatives in the bottom row, the solution has been found. And what is the solution? The max is p equal to 35. It occurs when x1 equals 10 and x2 equals 0. The only variables that we even keep track of are the x's, because those appear in our original inequality. The slack variables, the s's, those are irrelevant to the solution to the problem. They help us solve the problem, but they're not part of the solution. So when you come up here, you got these basic variables and you've got the non-basic variables, but the only 2 that we're interested in are x1 and x2. They become part of the solution, and so does p. P is the thing we're trying to maximize, so we're going to say the max is 35, and it occurs when x1 equals 10 and x2 equals 0. All right, they can even be bigger. So you can see this one here. See if you can pick out the basic and non-basic variables. What's the basic variable of the first row? All right, why don't you put your answer in the chat? I want to make sure that you're following along here. And if you don't know, just put a question mark and that'll tell me. If many of you don't know. All right, so I'm doing part A here, and it says identify the basic and non-basic variables. So we're going to start off by the basic variables. So I don't need a number like, it looks like you're writing 5 there, but I don't need a 5. I need a variable. Identify the basic variables. So we go over, and maybe you're a step ahead of me. So remember, we go over and identify the 1, where you have zeros everywhere else. So the basic variable of the first row is S1. And yes, S1 is going to be equal to 5. So if that's what you meant when you put 5, then yeah. So, but it asks for just the variables. All right, what's the basic variable of the second row, this row here? Go ahead again and write your variable name in the chat. Your choices are X1, X2, X3, S1, S2, S3, and P. There's 7 variables there. All right, so some of you think it's X2, some of you think it's S3, X3. All right, so you go over to find the 1, but you got to find the 1 where there's zeros everywhere else. So here's your 1 in the second row, and there's 0 everywhere else. And that column is titled S3. So S3 becomes the basic variable, and you can see S3 is going to be equal to 2, the number over here on the right-hand side. All right, give me the basic variable of row 3. Question mark if you don't know. Okay, that's right. So here's your 1, zeros everywhere else, and this column is titled X1. So X1 is the basic variable. And the last row is almost always going to be the same. It's going to be the value of your objective function. So you come over here, here's your 1, and P is the basic variable there. So X1 equals 11, and P equals 27. So those 4 numbers will correspond to the values of the basic variables. Now, the non-basic variables will be everything else. And everything else we set equal to 0. So we've got a value of X1, but we don't have a value of X2 and X3. So we're going to set those equal to 0. We've got a value for S1 and S3, but we don't have a value for S2. So S2 is going to be a non-basic variable, and we're going to set it equal to 0. The next question they'll ask is this the optimal solution? And what do you look for? Determine whether the optimal solution has been found. And the answer is it has not been found if you see negatives in the bottom row. So since there is a negative in the bottom row, you have to repeat. And so this is, we're going to repeat another set of row operations. And generally what we try to do in those row operations is we try to change these numbers here from what they are to a 1 and 3 zeros somewhere. We call this X2 the entry variable, and then we have another one that we'll label the exit variable. Okay, the optimal solution has not been found, so we need to go through another iteration of the row operations. All right, now I don't want to do too many row operations by hand here because they just take a lot of time. They're very tedious, and we're going to allow the calculator to do those anyway. I want to do the row operations, but I want to make sure that we have time for you to do one of these problems from start to finish using the Simplex program of your calculator. So I'm going to move down to, and I'll come back to the number 6. All right, so here's number 14. It's just we could solve this one graphically because it has just two variables in it. But for a maximum problem, you need to have all of these less than or equal to some positive number over here, less than or equal to a positive number for all your constraints. You need to have the basic constraints. And if that's the case, then you can solve this maximum problem. All right, let's go from this inequality system to an E system, and then from the E system to the matrix. Now, we're going to take and write, since we have the objective function and we have 3 constraints, we're going to write 4 different equations, with some with slack variables, others with not. Well, basically, in terms of our matrix, we need to have that x1 is greater than or equal to 0 and x2 is greater than or equal to 0, but those particular non-negative constraints don't actually make it into our matrix. All right, so here's how you transform these equations or inequalities. For the first one, you're going to write it as an equation, and you're going to get, there's no number in here. You've got 3 different variables and no numbers. You always want the number on the right-hand side. So this is going to become P, and then we're going to subtract 15x1 from both sides to bring that term over to the left. And we're going to subtract 20x2 to bring this term over to the left. And when we take these 2 terms using algebra and bring them over to the left, the only thing left is a 0. So this equation is identical to this equation algebraically. The next one, we have 2x1 plus x2 is less than or equal to 9. So the way we're going to rewrite that one is 2x1 plus 1x2. And here's where we introduce the slack variables. So if 2x1 plus x2 is less than or equal to 9, then we have some non-negative number s1, for which if we add s1 to this expression, we get something equal to 9. Writing those slack equations. After this, we're going to take those slack equations and put them into a matrix. The x1 plus x2 less than or equal to 6 similarly becomes x1 plus x2 plus a new slack variable that is larger than or equal to 0. And the last one is x1 plus 2x2 is less than or equal to 10. And that becomes x1 plus 2x2. This is a third constraint, and there's no guarantee that the slack variable I use here is going to be the same as an earlier slack variable that I've used. So I have to define a different slack variable there. All right, now once you have the 4 equations, that's going to translate into 4 rows in the simplex table. So the way we're going to write the Tableau is we're going to label, starting with the x's. We have an x1 and an x2, and that's it. No x3, no x4, just 2 x's. Then we're going to list all the slack variables, s1, s2, and s3. There are 3 of them. And then finally, we're going to list our objective variable, p, and then we're going to reserve the far right for the number on the right-hand side. Now we're going to have 4 different rows here. I usually separate. The first 3 are going to be the constraints, and we always put the objective function in the bottom row. We'll take them one at a time. This inequality contains the p. This is the one that goes in the bottom row. There is no S1, there is no S2 in here. So the S1, S2, and the S3 all take on zeros. This is P, which means it's 1P. And then we've got negative 15x1 and negative 20x2. Notice that there are negatives in the bottom row, so we have not found the maximum. Makes sense. We're just starting off with the problem. All right. This equation is going to appear in the first row. We have 2x1 plus 1x2 plus 1s1. There is no s2 in this equation. There's no s3, so we're just going to put zeros there. There's no p in that equation, so we'll put a 0 there. And then the right-hand side is the 9. So many of these rows are going to contain a lot of zeros. All right, the second slack equation is 1x1 plus 1x2. There is no S1 there, but we do have an S2. There's no S3, there's no P, and then the right-hand side is 6. Yeah, so we're just taking the coefficients from the E system and entering them into a matrix called a tableau. And the last one is 1, 2, 0, 0, 1, 0, 10. Over here, I forgot to add the 0. So this is called the initial simplex tableau. This is the matrix that we feed the calculator. So I'm going to do that next. So we're going to enter this matrix into the calculator. Now what the calculator is going to do is it's going to go through a bunch of row operations, and then as soon as it sees that there are no negatives in the bottom row, it's going to spit out the final matrix. We're going to write down the final simplex tableau and then read the solution from that tableau. All right, so I'm going to go into the matrix menu. I'm not running the program yet. The first thing I have to do is to enter in the matrix. And then when I run the simplex program, the only thing I need to do is to tell the program, oh, here's the matrix you want to use. All right, so we're going to go over to edit. And then we have to enter in this matrix. Now this matrix has 4 rows and 1, 2, 3, 4, 5, 6, 7 columns. So it's a 4 by 7 matrix. And then row by row, I have to enter in all 28 of these numbers. 2 and then 1 and 1 and 0, 0, 0, 9. 1, 1, 0, 1, 0, 0, 6. 1, 2, 0, 0, 1, 0, 10. And finally, negative 15, negative 20, 0, 0, 0, 1, and then 0. So enter this whole matrix in, quit out of the matrix menu, and now we're going to go run the program. So right here's the program key. If you have uploaded that simplex program into your calculator, you will see it. It's not going to look like my screen, but you should have maybe just one program there called Simplex. There it is, Simplex. So program Simplex goes to your screen. You hit enter, and it's going to say enter the simplex matrix, the tableau. Now, I don't have to re-enter this in because I called it matrix A. So I'm just going to go to the matrix menu here and select matrix A, our 4 by 7 matrix. So matrix A will be next to the input. And then we're going to hit enter and let the calculator do its work. Sometimes it'll pause. And if it pauses, you'll see up here in the upper right, I don't know if you can see that, you just got something fluttering. That means you're not to the final solution. If you see that, this means that it's gone through one round of row operations. You can see there's a negative in the bottom row, so it has not found the final solution. So it goes through another iteration, and when it's ready, it'll report the final simplex matrix. And then I'm going to write down the final simplex matrix. So while it's pausing here, I'm going to write down this entire matrix. So 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0. And we've got a bunch of negative 3, 2, negative 1, 10, 1, negative 1, 1, 5, and 0, 0, 0, 1. Okay, and then finally 1, 2, 4, and then 110. All right. So this is the final matrix, and then it says it's done. Now what we have to do with this matrix is the same exact thing that we did before. First of all, you're going to take the same column headings here and bring them down. X1, X2, and then you have S1, S2, S3, P, our objective, and then the right-hand side. Same as before. Now, we're going to identify the basic variables and the non-basic variables. And the reason we had you do this to begin with is because by identifying the basic variables and the non-basic variables, you're actually identifying the solution to the problem. Notice there are no negative numbers in the bottom row. So we do have a solution. The basic variables are. So go over till you find a 1 with zeros everywhere else and label that row S1. Second row, find the 1. Usually it's a 1. Zeros everywhere else. So X1 is the basic variable of the second row. Go to the third row, you got a couple of 1s, but here's the 1 that has zeros everywhere else. And this row is titled X2, so X2 becomes the basic variable of the third row. And then for the fourth row, it's always going to be the objective functions value variable. So P. And then to get partial solutions, you list the values of the basic variables and then write down all the variables that remain. And those are the non-basic variables. And the non-basic variables take on the value 0. So S1 is the first basic variable, and its value is 1. X2 is the second basic variable, and its value is way over here underneath the right-hand side, 2. That's X1. X2 is the basic variable of the third row. Go all the way over to the right, and you'll see 4. And then finally, P is the basic variable of the last row. You go all the way over, and you get 1/10. The variables that we have not used are X3. No, we don't have an X3. We have X1, X2, S1, S2, and S3. Those are the other 2 variables that do not have values. So these are the non-basic variables. Now, when you report the answer, you're only going to report the X's and the P. The S's are slack variables, or like dummy variables. We use them to help us solve the problem, but they're not actually in the problem. The original problem was something like this. It had all these inequalities in it. There's no S's in the original problem. So from here we say the max is 110. It occurs when X1 equals 2 and X2 equals 4. And that's it. We don't have to report any of the S's because they're not part of the original problem. But you have to interpret this matrix in order to get the solution.